Good day, everyone. Welcome to another episode of our SQL Server query tuning series. In today's video, we are about to dive into a powerful tool that holds the key to unraveling the secrets of your SQL Server's performance, unveiling the power of DBCC show statistics. I'm thrilled to be your guide on this enlightening journey into the heart of query optimization. If you ever wondered how SQL Server makes decision about execution plans, you are in for a treat today. We are unleashing the power of a command that opens the door to a treasure trove of insights, the mighty DBCC show statistics. Have you ever found yourself scratching your head over slow query performance? Ever wished you could peer into SQL Server's mind to understand how it's handling your data? Well, that's exactly what we are about to do today. DBCC Show Statistics is your backstage pass to the world of statistics, those critical pieces of information that influence how queries are executed. But don't worry, we are not just diving into theory here. This video is all about practicality. I will walk you through the step-by-step process of using DBCC show underscore statistics command to analyze existing statistics on a table. We will decipher the results, explore the intricacies of data distribution, and connect the dots between statistics and query performance. So whether you are a seasoned SQL pro looking to fine-tune your skills or a curious learner eager to demystify the inner workings of SQL Server, this video has something for you. By the end, you will be armed with insights that can transform your queries from sluggish to lightning fast. Get ready to unveil the power of DBCC show underscore statistics as we venture into the heart of SQL Server's query optimization engine. Buckle up because we are about to turn the tables on query performance. I'll be using database AdventureWorks DW for this particular demo. Let's list out the available statistics on object table 1. And if you see here, we have close to 5 statistics. And out of these 5 statistics, we have one auto-created statistics, and everything else is like created either as part of an index or was created manually. And if you see here, column 5 and 6, basically like these two rows are one and the same, created as part of statistics stats underscore column 2 underscore column 3. What we'll do now is like we will pick up this particular statistics, which is created as part of the primary key, and then look at the values as far as DBCC show statistics is concerned. So let's execute this query. And if we see here, we don't have the statistics populated with any value, and that's because we never ran a query using predicate column 1. So what we'll do now is like let's try executing this query, which selects column 1 and column 2 from object table 1, and the predicate is column 1, which will utilize your statistics that was created as part of the cluster index. So let's run that and then check the DBCC show statistics value again. So this time what I'm able to see is like the values are all populated here, and also like we have 3 components as far as this DBCC show statistics command is concerned. The first one is called your stat header. The second one is called the density vector, and the third one is called your histogram. So now what we'll do is like we will look at the auto-created statistics, which is created as part of the column 3. This is the one. So what we'll do is like we will check each of these components as far as the DBCC show statistics is concerned. That is your stat header, density vector, and histogram for the statistics that is created on column 3. So now If you look at the command here, if you run DBCC show statistics without any switch, what happens is like it lists all your components, that is your stat header, density vector, and histogram. And if you use the switch specifically, for example, if you use with stat header, it's going to give you the stat header information only. Density vector is going to give you only the density vector details, and histogram is going to display you the histogram details. Okay, so now the first command that I'm going to execute is dbcc show statistics table name statistics name with stats header, which is going to show me the stats header details for this particular statistics. If you look at it, yeah, this is the statistics name that we have used, and updated basically tells us like when was this statistics last updated, and we know like we created it just now, so this is the time it was last updated. And the first time the statistics is created, it gets updated as soon as the statistics is used in a query. And now rows basically tells us like we have close to 1,499 rows on this particular table 1, when the statistics was updated. For example, whatever was the row count at that point in time will be placed in this particular column. And row sample basically tells us like how many rows were actually updated when the last update happened as far as this statistics is concerned. In our case, rows is 1499 and rows sampled is also 1499, which basically tells like the sample rate was 100%, or it was a update statistics with full scan, or since it was the first time we created this statistics, it is always going to be a full scan. And steps, which shows us 4, basically tells us like we have this many number of histogram steps. Moving on, we will now check the details about the density vector for the same statistics. So if we see here, the all density value is 0.166667, which is basically like if we round it off, it will be 0.17. And the way that we calculate all density is like we basically divide number 1 by a distinct value of column 3 on table 1. So if we look at the calculation here, we are basically dividing value 1 by distinct rows of column 3 from table 1. So let's execute this, and we are seeing the same value. So what we'll do now, we will basically execute both these values, both these queries. And if we see here, the DBCC shows statistics, density vector basically shows the all density value as 0.17. I'm rounding it off. And then the calculation that we did using a select statement, 1 divided by distinct rows as far as column 3 is concerned on table 1, both are same here. They are one and the same. So if we round it off, it will be 0.17 here, and here also it will be 0.17. And this is how we calculate the all density value. We will discuss further at the later stage, like where and how this particular all density value will be used by the optimizer for coming up with estimates. But right now, let's move on and then look at histogram. So the command uses dbcc show statistics, table name, statistics name, and the switch would be with histogram. So if we see here, we have like close to like 5 columns here: range high key, range underscore rows, EQ rows, distinct underscore range rows, and average underscore range rows. Basically having this command so that it will be easier for us to understand. So range high key basically gives us the upper bound column value for a histogram step. In other words, these are the actual values that is present as far as column 3 is concerned in table 1. Yep. And range underscore rows basically is the estimated number of rows whose column value falls within an histogram step, excluding the upper bound value. So basically like it tells us like between these two histogram steps, we have this many estimated number of rows. That is between 1 and 3, excluding the upper bound. And same way, between range I key 3 and 5, we have this many number of rows, which is falling between this and this value. Yep. And as far as EQ rows is concerned, it is the number of rows whose column values equals the upper bound of the histogram step. For example, it basically tells like EQ rows basically tells like we have close to 100 rows as far as the range IQ1 is concerned. And that is same for 3 and 5 also. And as far as range IQ 6 is concerned, it basically tells like there are close to 999 rows. Distinct range rows can be defined as a number of rows with a distinct value within the histogram step, excluding the upper bound. So here, if you look at it, like as far as column 3 is concerned, we have values 1, 2, 3, 4, 5, and 6. And if we look at it here, basically like between these two range high key, we know that between 1 and 3 we have 2. And that is what is mentioned here. The distinct range rows is the distinct value that is buried between these two, excluding the upper bound value here. And that is same for these two also. And if we look at 5 and 6, we know that there is nothing between 5 and 6, and that's the reason we have a value of 0 here. Now coming to average underscore range rows, it is the average number of rows with duplicate column values within histogram step. Again, it is excluding the upper bound. It is basically, for example, if you see here between 1 and 3, we have close to 100 rows with duplicate column values. And also when distinct range rows, for example, if the distinct range rows is in here is greater than 0, then average range rows is calculated by dividing range underscore rows, like you will be dividing range underscore rows by the distinct range rows. For example, when you have this value greater than 0, what we basically do is like we divide this range underscore rows by distinct range underscore rows. When distinct underscore range underscore rows is 0, then average range rows is always 1. Yep. Now let's look at this command again. So if you see here, what I'm able to see is like we have these range high key 1, 3, 5, and 6. So now what we'll do is like we'll execute this command, which basically lists out all the distinct value of column 3 from object table 1. I'm ordering this particular query output using column 3. So let's execute that. So what we'll do is like we will execute both of these so that we can compare it. And if you see here, as I told you earlier, column 3 has distinct values from 1 to 6, which is 1, 2, 3, 4, 5, and 6. And if you see here, as far as the histogram steps are concerned, we have value 1, 3, 5, and 6. Yep. Now we know that range underscore rows is basically your estimated number of rows whose column values falls within an histogram step, excluding the upper bound value. So we know that as far as column 3 distinct value is concerned, it is 1 to 6. So now what I'm going to do is like, now we have these range high keys 1, 3, and 5, and 6. So what I'm going to do is like, in order to calculate the range rows, what I'm basically doing is like I'm selecting the count from table 1, and the predicate used is column 3 greater than 1. Since we are going to exclude the upper bound, I'm using a greater than 1, and then column 3 is going to be less than 3. Yeah, and using the same thing for other things also. Like if you see here, our first query is for these two steps, second query is between these two, that is 3 and 5, and the third query is between these two, which is 5 and 6. So let's run this one and then see if we are seeing the same value. So if you see here, range I key, since we don't have an upper bound value here, so it is always 0 here. And as far as this one is concerned, we have 100, and we see that 100, 100 and 0. So we have 100, 100 and 0. So that is how we calculate range underscore rows. Now what we'll do is like we will calculate the EQ rows, which basically tells us the estimated number of rows whose column values equals the upper bound of the histogram step. Yep. So if we see here, we know that the range high key is 1356. So what I'm doing is like I'm doing a count of a count from table one, and the predicate basically has the range high key, which is 1356. If you see here, it is 1356. So let's execute that and then see if we are getting the same value. So if you see here, for 1, 3, and 5, 1, 3, 5, and 6, we see 100, 100, 100, and 99. That is 3 times 100 and 1, 999. And if you see here, it is one and the same 100, 100, 100, and 999. So that is how we come up with the EQ rows. As far as distinct range underscore rows is concerned, we know that it is the estimated number of rows with a distinct column value within a histogram step, excluding the upper bound. So range I keys, again, it is 1356. So what I'm going to do is like this time I'm going to calculate a count for distinct values of column 3 from table 1, and then I'm plugging in the um, range high key values here. So column 3 is greater than 1 and then less than 3, and the second one is like basically like column 3 is greater than 3 and then less than 5, and the third select query basically has the range high key as greater than 5 and then less than 6. So now let's execute this one. And then if you see here, what we are able to see is like since we don't have an upper bound value, it is always 0 for the first one. And for rest of the things, what we are able to see is like we are able to see we have as far as this particular step is concerned, we have one distinct row, which is the value 2. So that is mentioned as 1 here, and between these two we have 4, which is so since it is 4 that is coming between these two, so we the count is 1 again, since it is only one number, and 5 and 6 there is nothing, so that is the reason we are seeing 0. And if we see here, it is same like what we have calculated, 1, 1, and 0. Now let's calculate average underscore range rows. So now if you look at it, average range rows is the average number of rows with duplicate column values within an histogram step, and we will be excluding the upper bound value. And when a distinct range row value is greater than 1, then what we do is like we basically divide range underscore rows divided by your distinct range rows. So that's what we do. So here it is, so if you look at the values here, so these two things is 0. So in case of distinct range rows is set to 0, then average range row is always 1. Okay. And for the calculation here, what we'll be doing is like since these two things are greater than this, these two things as far as distinct range rows is greater than 0. So what we'll basically be doing is like we will be dividing the range underscore rows by distinct underscore range rows. So now look at this one here. So what we are doing is like to get the average underscore range rows, we are basically like dividing the range underscore rows by the distinct value of column 3, which is basically your count is your range rows, and count distinct column 3 is your distinct underscore range rows, and we have the histogram step values inserted here. So 1 and 3. So we have put in 1 and 3 here, and then 3 and 5. We have not put 5 and 6 because we know like distinct range rows is 0. So average range rows would be 1. So let's execute that. And if you see here, we are getting this value 100 and 100. So this is how we calculate the average underscore range rows. These are things just for our understanding. There is no requirement that we need to calculate all these things. It will all be done automatically by SQL Server, but just for our understanding, basically mentioning it here. what we'll do now is like we will check the histogram value for multi-column statistics. Yep. So right till now we were looking at single column statistics, but what we'll do now is like we will check we will use a multi-column statistics, and then we will check the histogram step for the multi-column statistics. So let me execute that, and then I will pick up this particular statistics, which is a multi-column statistics. For example, if you see here, stats underscore column 2 underscore column 3 basically has the columns column 2 and column 3. So what I'll do is like I'll pick this up, and then I will execute this particular command here, which is your DBCC show statistics, object name, and the multi-column stats. And I just want to look at the histogram, so I'm using this with histogram. So now you execute this particular query. So if you see here, I'm able to see that I'm getting the information. Now I'm using column 2 and column 3. One thing to remember as far as multi-column statistics is concerned, histogram steps will be derived from the leftmost column, no matter how many columns you have. For example, right now, this multi-column statistics has got two columns, column 2 and column 3. And the histogram step is basically derived from column 2. So let's consider we have like four columns, column 2, column 3, column 4, and column 5 in statistics. And if you look at the histogram there, then the histogram steps will basically be derived from the leftmost column, which is column 2. So that is how the histogram step will be derived. Let's execute these two queries here. And if you see here, I'm just selecting the distinct values of column 2 and column 3, and we have this many values. But if you look at the histogram step, it is always like the range high key is the leftmost column, which is your column 2. Yep. So no matter how many columns you have in the statistics, the leftmost column on the statistics will always be used to derive your histogram step. Let's drop the statistics that is not required for any future demos. That's it for this video. Thanks for watching. Have a great day. Jai Hind.